Hi, guys. Woo! Review time. I'm hyped. I hope y'all are hyped. I don't remember the point I had. This one? This one? Okay. All right. So, let's do it. I hope y'all's weekend's been good. My name is Mr. G. No, that's too big of a point. That's better. Okay. So, I'm gonna go through this pretty quick. Nothing crazy. I'll try to explain through it as best as possible without wasting too much time, because some of these are gonna be pretty easy for most of you, especially at the beginning here. So, let's get to work. So, domain and range, obviously, domain is X, range is Y. These I told you to treat as continuous functions. So it's going to go forever left, forever right. So I'm going to have negative infinity to positive infinity. My range obviously comes down to just here. Nothing comes below that. So obviously it's kind of off that -3 a little bit, but we'll just pretend it's there. And it's going to be included. Why is it going to be included? Because it's a closed circle. Right. Again, domain is X, range is Y. So domain starts here at -3. That's going to be parentheses just because of the open circle, and then it comes all the way over here to a 1, 2, 3, 4, 5. And that's going to be a bracket. Range goes down to -1, 2, 3, 4. Here, I'll make it a different color. So right here, -4 up to +3. And then domain over here is going to go from -4, close circle, close bracket, to infinity, while range goes from -3 to infinity. Okay, super simple, nothing crazy. Number 2, even easier. We kind of went through this as well. You just plug in numbers here. So these 3, 1, 2, 3. Let me zoom in so I have more room. So you just plug them in. So 2 times 0 minus 10, -10. Oh, it's terrible. That's going to be your first point of range. And then you plug in 1. This is going to be super boring to start this because everyone knows this. And then we'll plug in the 2 over here. 2. So that's it. Easy, easy, easy. Right, come over here. It's the same concept. Plug that in. Plug this in. Plug this in. So 2 times 0 cubed plus 4 is just going to be 4. That's your first one. And I'll stop talking for the rest of these because it's really easy. 1 cubed is 1 times 2 is 2. 2 plus 4 is 6. And then we'll plug in the 2. 2 cubed is 8. Do not say 6. So 2 cubed is 8. 8 times 2 is 16 plus 4 is 20. There you go. Pretty simple. These transformations, hopefully after seeing these a couple of times, you guys remembered. These are always going to be important for the rest of Algebra 2. Transformations are going to continue to be a topic we bring up. Right now it's just quadratics, so we've been talking about quadratics for a while, but we're going to continue on to other functions, and those functions will be transformed as well. So do not forget these. Remember, when we subtract on the outside like this here, then we're moving down 3 units. Remember, when it's outside that x, it's affecting the y. y, you think of up and down. So there you go. This negative on the outside, I don't know why I did that. Oh, that's terrible. Oh well. Okay, this negative on the outside is affecting the y, but when y values go from positive to negative, it flips over the x-axis. So reflect over x-axis. Remember, just because the y values are affected does not mean it's reflecting over the y-axis. And then this 2 here is affecting the y, so it's got to be a vertical something. Vertical. And then if you were to put 2 on an x squared or anything like that, 2x squared, that would be a vertical stretch. So remember, when you multiply by anything over 1, it's going to stretch it. If you multiply by a fraction, then it's going to compress it. Second one, you're affecting that x. So remember, the x was opposite on the inside, so you think a negative would go left, but that is just the opposite of what you may think. So that minus 4 on the inside there is going to move it right 4 units. And then this one has both. So remember, opposite on the inside, so the positive is going to move it left 5, and then the 4 on the outside is going to go up 4. Okay, this one's pretty simple. I had rearranged this stuff for my regular students, but you guys should be able to go kind of back and forth throughout topics. So this one kind of brings up parent functions, even though later on you kind of go through those parent function ones. I think it's toward the end that you talk about every single parent function. But let's plot these. I'm going to plot them really quick and then resume the video. Okay, so with those points plotted, we can clearly see that this represents an exponential function. Oops, it's okay. Exponential. 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 It's not how you spell it, obviously. Exponential. Woo! Okay. So yeah, so if you weren't kind of sure what this would look like, or if you don't remember your parent functions, then later on you'll be able to see those things, and you can come back and refer to this, and you'll see it is indeed an exponential. All right. So number 5, so remember when I was explaining this, I was calling this my little pointy point up here. I like that little guy up there. So we said that that was at -5, 4 ordered pair. So we bring that over here to the transformation. -5, 4 is going to be right here. And we count the distance that it travels right and down to get to the other pointy point, the new pointy point. So we go right 1, 2, 3, and down 1, 2. So right 3, down 2. Now we just write that in. So f of x, f of x, if we're going right 3, we have to subtract by 3 on the inside, and then down 2, we have to subtract by 2 on the outside. Right? Same concept for the rest of these. Same exact thing. So my little pointy point's right here, -2, 2. So I'm going to put that here, and I'm going to count the distance to the new pointy point. So I go up 1, 2, 3, 4, 5, and over 1, 2. So up 5, right 2. Same concept here. F of x, if I'm going right, I'm subtracting. And if I'm going up, I'm adding on the outside. Then down again. Number 7, same exact concept. My little pointy point's up here. That is at, 2, 4, 6, 7. So 0, 7. So I put it right up here, and I count. Left, 1, 2, 3, 1, 2, 3, 4, 5. And then down, 1, 2, 3, 4. So left 5, down 4. So So f of x, if I'm going left, I'm adding to the inside, and if I'm going down, I'm subtracting on the outside. There you go. Oh, great. Uh-oh. I don't have my calculator, and I'm not going to do this by hand. Where? In the black box. Is it a graphing calculator? No. Oh, nope, can't do these things. Okay, so, yeah, so you just do menu 3, 2, I think, and then you change the variable to 3 variables, and then you just plug this exact thing in, and you'll get the answer. I'll have that answer in class. I can just do it really quick, but I don't have the graphing calculator, so you could do it by hand, but I'm not going to do that because that would take forever. So let's go down to number 9. So I have 2 equations here, 2x plus 3, negative 3x plus 8. So you just graph them, guys. This is simple Algebra 1 stuff, really. This isn't even Algebra 2. A lot of you did this in 8th grade. Same exact thing. So this first equation here, I'll do in green. So I graph the y-intercept first, and then I plot the slope, which is 2. So up 2 over 1, up 2 over 1, up 2 over 1. Make that line. Doesn't have to be perfect because I know where this is going to intersect. This 3 here. I'm sorry, the second equation is going to be red. So I'm going to plot the the y-intercept, 2, 4, 6, 8. And then my slope is negative 3. So I go down 1, 2, 3 over 1. What do you know? There's my guy right there. So my solution is going to be 1, 5. Yay. Okay. Down to number 10. The side of a square equals the width of the rectangle. So this one was really visual. If you just read this, and some of you might get it, some of you might not. So definitely draw it out, right? So I have a square here with a side of x, and that shares a side of a rectangle, shares the width of the rectangle, and makes a length, right? So the width of the rectangle is going to be the same exact thing as my square, and the length is going to be 6 meters longer, so x plus 6, right? And then the sum of their areas is that. Sum is addition. Areas, you know the area formulas. So really and truly, this shouldn't be too difficult for you. You might just kind of get lost in the words, but just take your time here. So area of a square is x squared, and we're adding the area of the rectangle, which is x times x plus 6, and we know that's going to equal 176. Right, so then we simplify this left side as much as we can, distribute this x. Right, and then we can combine those like terms. Let me come over here. So I have x squared plus, 2x squared plus 6x equals 176. Then I can solve this just like any other quadratic we've ever used, right, ever done. So I'm going to bring that over here. Then I can factor. First I'm going to take out a 2 before I factor these, just to simplify. So I'm going to divide everything by 2. So I'm going to have x squared plus 3x minus 90 would be 180, so 80, 8. Right, and then factors of 88, that will add to be positive 3. Luckily, it's the easy one, 8 and 11, right? So factors of this is going to be, you need it to be positive, so the 11 has to be positive, the 8 has to be negative. So my factors are x plus 11, x minus 8. And so my roots are the opposite of that. And we cannot have a negative side length. That would make no sense. Negative side length would make absolutely no sense. So the only possible answer is x equals 8. So our answer is x equals 8. Right? Pretty simple. I know it's kind of weird, kind of wordy, but once you get to it, it just turns into a quadratic. And that's what we've been working on. Right? Number 11. My God, those of you who said number 11 was hard. Oh God. Okay. It's just, so all you're doing is just interpreting a graph, guys, and these are two linear graphs. Should be pretty simple, right? The only reason why this could be difficult, I guess, is if you overthink it, think it's going to be harder than what it really is, but it's really not. So first, will the company have a loss or a profit when the 50 skateboards are sold? So 50 skateboards is here, right? I'm going to make a dotted line to go up. If revenue, which means how much money you're making, this is money, check. This is money lost, right? So if I'm making more than I'm spending, then obviously I'm making a profit, right? How much money did the company make when 20 skateboards were sold? Right here. So how much money did they make? My revenue right here is $500. Right? So $500. Yay. Right? How many skateboards were sold when $1,000 was made? Oops, sorry. Let me do it in blue. So $1,000 is over here. Looks like it's darn near lined up with 60. So 60 skateboards. Again, guys, this is just interpreting a graph. You really weren't supposed to find this so difficult. And then this one, when will the company break even? That's just when it intersects right here. So again, it's kind of off that 30. It's fine, right? I can say 31 or 32, or you can say 30. It doesn't matter to me. As long as you know that it's where the intersection is. The test is not going to leave it kind of up for interpretation like that. It'll be more exact, but just for fun, let's say 31. 31 skateboards sold. Right. Good. Okay, number 12. Let's do it. So, solve by elimination. Luckily, these guys are already set up for elimination. Our y's are opposite, so I just have to add these two equations. Let me zoom in here. So 2x plus x is 3x. Positive y plus a negative y is going to cancel out. So 3x is going to equal 9. Divide by 3. Oops. X equals 3. Then I got to plug that into one of these original equations. Let's plug it into this second one. So I'm going to have 3 minus y equals 6. I'm going to subtract 3. So negative y equals 3. So then y equals negative 3. Boom. Easy. Right. Solve using substitution. Again, they gave you an easy one. They already tell you what y is equal to. So if x plus y equals 12, and then it tells you y equals 5x, all you do is plug it in. So instead of writing y on that first equation, you write what it's equal to, 5x. Then you simplify. 6x equals 12. So x equals 2. Right, plug that into one of your original equations. I'm going to plug it into the one I have circled. So y equals 5 times 2. So y equals 10. And what I did not write on the last one, which I will go back and do right now, is I want your answer in an ordered pair. Right, so back here, my ordered pair should be 3, negative 3. And lastly, this guy over here. This one is a little bit more difficult. You just have to multiply one of these equations to get, so you can do it both ways. You can either solve for y or solve for x and use substitution. I'm more of an elimination person, so I like to make things opposite. So this first equation I'm going to multiply by negative 2y, so I can get a negative 4x that will cancel my x's when I add them, right? So I'm going to have negative 4x minus 10x equals negative 38. And then I'm just going to rewrite this second equation. Okay, then add them. These will cancel out. This will end up being negative 13y. This will be negative 39. Then I can divide. Divide by negative 13. And my y ends up being 3. All right, I'm going to plug this into this bottom equation here. So 4x minus 3 times 3 equals negative 1. Then just simplify algebra 1. So 4x minus 9 equals negative 1. Add 9. 4x equals 8. There you go. So your ordered pair is 2, 3. Bam. Oh. Okay, hopefully you guys remember those. Yeah, easy. So, number 13, inequalities. So, remember I told you guys that inequalities are the same exact thing, except it requires shading above or below, and dashed or solid line depending on what the sign is. So first, solve these for y. So my y is going to be less than x plus 3. And this one is going to, I forgot, let me work this out. So I'm going to subtract 4x from each side. So I have 2y. Is less than or equal to negative 4x minus 2. Divide everything by 2. So you should get y equals less than or y is less than or equal to negative 2x minus 1. Yep. So then you graph these. So first one I'm going to graph is the red. So I graph its y-intercept, and then the slope is 1, so it just goes diagonally. Remember, it doesn't have to be exactly perfect. And then here, my y-intercept is negative 1, and my slope is down 2 over 1, down 2 over 1. Oops. It's okay. All right. Yeah. And then I got a graph. Oh, silly. I'm an idiot. Oh, you know what I could have done? Back. Yes. Okay. I'm just going to make this dashed. Yeah. Nice. Nicely done. Okay. So yeah, that red's going to be dashed because it does not include. So where am I going to shade? In the red, I'm going to shade below because less than means shade below. So all of this gets shaded. And with the blue, I'm also going to shade below. So where do they overlap? Right here. That's going to be your answer for shaded. Okay. Nice. Still got a long way to go. Jeez. Okay. So, factor each of the following. We did this one, I think, in class. But let's do it. So, oops. This is really just this. So your b is 0, right? So it's the same concept. I have to come over here and find factors of negative 81 that add up to 0. That's going to be 9 and negative 9. So those are my factors. A plus 9, A minus 9. Easy. Right, over here, same thing. Factors of 45 that add up to negative 14. That's going to be negative 9 and negative 5. So those are your factors. This one, don't forget A times C. Right, so that's 12. What factors of 12 give me negative 13? That's going to be negative 12 and negative 1. So I'm going to substitute those in. Right, remember, do not group these like this. Do not do that. Okay, you need a positive in between. So when you group them, like this with a positive in between. Remember, that negative is going to kind of lead you to make mistakes. That's not what we want. So leave the negative with that coefficient and just move it over and put a positive in between the two groups. Now, what do they share in common? This one shares a 3a in common. Take that out. This one, you can just take out a negative 1, to make it a minus 4. And then take that a minus 4 out of both terms, and what's going to be left? The 3a minus 1. And there you go. There's the factors. All right. Here, if area of a rectangle is this, and its width is this, what's its length? So we know length times width equals area. So basically, it's just telling you, you know, what times 2x is going to give you that. So let's set that up. 10x plus 6x squared equals 2x times the length. So all you're doing is dividing by 2x, both sides. This you have to split off. So you have to, let me erase this. Okay, so you have to split this off. So 10x over 2x plus 6x squared over 2x. That's going to be 5 plus 3x. And there's your length. Okay, down here, find the perimeter and the area. Yeah, I'm going to write these out without talking. Okay, so basically perimeter is just combining like terms. You're going to add all the sides up, combine them. You should get 12a plus 18. And then your area, you're just going to FOIL. So, yeah, FOIL it, combine like terms, and you should get 5a squared plus 29a plus 20, right? Down here, 17. So it just gives you the volume, and it wants you to solve for the radius. So pretty simple. Honestly, guys, remember, you're going to have a calculator for this. I would just solve it. But you can very well do this by hand, and I will. I'm going to zoom in and make this smaller. So, yeah. So you can solve it. So first, I'm going to multiply by the reciprocal here. So to get rid of this guy, so multiply both sides by 3/4. Right, so that means this and this will cancel. And then, I could use a calculator. I'm going to use my phone for a calculator. I don't feel like doing that in my head. Oh my god. So 5573 times 0.75. Oops. Oh, that gives you decimals. This is fun. Woo! Everyone loves fractions. Okay. Yeah. Hang on. So that's your answer. you can do it on the calculator and stuff like that. But like I said, just use InSolve. Right? Don't stress yourself. Don't work harder. Right? You can save time with this kind of question on the test just by using InSolve. So here I told you to skip number 18 because it didn't give us enough information. Here, pretty easy, guys. This one's 3i. Right, this one, you can do this a number of ways. Not a whole bunch of ways, but some different ways. So I'll just show you the way I did it, and then, we should end up at the same result at the end, though. So what I did is I took out the i's first. So here I had I square root of 12 times I square root of negative 2. Oh, I'm sorry, positive 2. Right, and then I just multiplied. So I times I is I squared, and the square root of 12 times the square root of 2 is going to be the square root of 24. I squared is negative 1, so this ends up just being negative square root of 24. And then I can simplify that by saying perfect square is 4. So it's going to be negative 2 square root of 6. Okay, because 4 times 6, let me do that out real quick. 4 times 6, and then the square root of 4 is 2, right? So that's that. I'm just going to do a couple of these guys, and then I'll put the answers for the rest. I know this video is already over 30 minutes long, so I don't want to waste a whole bunch of time. So I'll go through 2 of these, and then like I said, I'll just kind of pause it, do them, and then resume it so that all the rest of them will be up. You can pause it and copy them down if you want. Okay, but this first one, actually I'll skip this first one. So this one, remember you got to divide by 3 first. A lot of people want to distribute that 3 or, do anything else with that 3. You got to divide it first. So then this is just going to leave this. Right, and then you can square root. Right, so then here I'm left with 2x minus 8. And the one thing everyone will probably forget is plus or minus. Oops, do not forget plus or minus. Right, and then it just turns into the same stuff. Right, we got to add 8 to both sides. Remember, this goes in front. So I have 2x equals 8 plus or minus 2. Then I can divide by 2. Oops. Oops. Right, so then I do both. 8 plus 2 over 2 and 8 minus 2 over 2. So this is going to be 5. This is going to be 3. Right. Coming over here. So same concept, right? Except now I don't have the square root outside the parentheses. Now I just have it with the x. So I've got to isolate that before I can take any square roots. So I just have to subtract 120. Divide by 2. And then I take the square root. And don't forget the I or the plus or minus. Right, so pretty simple. I'm going to do the rest really quick and then unpause it so that all the work will be here. You can pause it then and copy it down and make sure you're right. Okay, so that one has everything done. This one over here, I don't know why. Remember, I didn't make this review, so I don't know. I mean, you can pull the 8 over and then factor it the way I did there. But, I mean, I don't know what they want you to do with that. You can't solve for x that way. I mean, that'll give you your roots, I guess, which I guess you're solving for x there. But, yeah. I don't know. So your roots are going to be what? X equals 4 and x equals 2. But I'm not sure why they put that. So down here, graph the following. Guys, these are just in vertex form. Meaning 2, 1 is your vertex here, and -2, -3 is your vertex here. I'm not going to sit here and graph it because it doesn't have like the lines, like your y-axis and x-axis. And you can use your calculator, so I'm not going to worry too much about that one, guys. But when we come down to discriminant, that's when it's going to matter, right? So let's use the discriminant here. So discriminant is going to be b squared minus 4ac, right? So let's plug these in. So b squared is going to be 3 squared minus 4 times a, which is 1, times c, which is -18. 3 squared is 9. And 4 times -18 is going to be 72, I think. So subtract a negative, that's going to turn into a positive. So that's going to give you, what, 81. And since it's positive, remember discriminant with that worksheet, whenever your discriminant is positive, you're going to have 2 real roots. Right? So that's for the first one. The second one down here, how many real roots does this one have? Same thing, guys. So again, b squared. Oh my god, what happened? What? What's going on here? Oh, I went to marker. What an idiot. Okay, pen. B squared minus 4ac. This one doesn't even have a b. So 0 squared minus 4 times a, which is 1, times c, which is 2. So that's 0 minus 8. That's -8. So this one's actually going to have 0 real roots, because when you have a discriminant that is less than 0, you have 0 real roots. You do have 2 imaginary roots, which we will get to in number 24. So this is the same exact thing, guys. So yeah. So we're going to have a guest do these 4 for you. So
Hey guys, it's been about 7 years since I took algebra, but we're gonna just bear with me for a second. Okay, so as I recall, it's 2a squared minus 4c. Is that the formula?
No.
What is it?
b squared minus 4ac.
Oh,
There it is.
okay,
There it is.
not that.
There it is. Yeah.
Okay, alright. So, we're going to do that, put it in parentheses, because Mr. G told me to, and then your A is that guy, your C is that guy, and then you solve it. So, oops. That's not the eraser. Okay. Alright. Let's see. It's going to be 8 times 3. So we got 49 minus 24. And that is 25. So since it is positive, since it's greater than 0, that means you have 2 real roots. Alright, next problem. We are going to do 5 squared minus 4 times 1 times 24. So you have 25 minus 4 times 24 times 4. It's going to be 25 minus 96. Then you get a -71, and since it's less than 0, you have 2 imaginary roots. Sorry for my terrible handwriting. Okay, next problem. Okay, you're gonna do -4 squared minus 4 times 4 times 2. It's gonna be 16 minus 16 times 2. It's gonna be -16. So 2 imaginary roots. And the last one over here. Oh, I guess I have to make it look like these guys over here. So, how do I do that? It's going to be 4x squared minus 12x minus 63 equals 0. Is that right? Maybe? I don't know.
What happened?
Okay, I'm pausing it.
Yeah, you're good.
Wait, I did this right?
Mm-hmm.
Okay, cool.
Mm-hmm.
So, negative
Yeah, just make sure that's in parentheses.
12 squared. Minus 4 times 16. Oops, just kidding. Minus 4. Okay. So that is going to be 144 minus negative. The A is it?
It's 4AC. 4 times A times C. You forgot another 4.
I'm just kidding.
Just regret it.
Uh-oh. It's not working. It's not erasing.
Just rewrite it. Just rewrite it. Yeah, just cross it out and rewrite it.
Okay. Minus 12 squared minus 4 times 4. Times negative 63. So that's 144 minus okay, 144 minus negative 63, 16,008. It's going to be like adding it, and that is 1152. So 2 real roots. Okay.
All right, so I'm back. Everyone give a round of applause for for your special guest from before. Hopefully she explained it pretty well. But really, I mean, just to go over it, you're just plugging into that formula, guys. Nothing crazy. Really and truly, you can put this. You can put this into your calculator and not worry about anything, right? And then just see what you get out. But yeah, so that's discriminant. Remember, the reason why those negatives, when you have a negative discriminant, it has 2 imaginary roots, because it does not touch the x-axis, right? So it doesn't have any real roots. Those are the kind of things that kind of look like this, right? That they don't touch the x-axis at all, but they do have imaginary roots. We just can't see them. So moving on, these guys are pretty easy, okay? Since the axis of symmetry is right here, what it reads to you, then you just mirror. So 1 over is going to be right here. 2 over is going to be up here. So when you do that, then what it's asking is between which values will the other one be. So obviously, if you zoom in there, It's going to be between 5 and 6. Right. Same thing down here. It's just asking you what the other 0 is going to go in between. So again, it just mirrors across that axis of symmetry. So here, here, and then here. Connect. So where does it go in between the x-axis? Between 0 and -1. Pretty simple. Okay, coming down here, guys, so you can do this in your calculator. Just graph it and find max height. But yeah, so really all you're doing is going here, graphing this, right? And then you go into graph. Once you graph it, you got to make it fit. But really all you're doing is menu, analyze, maximum. Once you do that, the answer to this one is going to be your y value of that maximum. The answer to this one is going to be your x value of that maximum. And then here you're just finding that other 0. So find 0, which is your x-intercept, other than 0. Right? Because what it's gonna happen, it's gonna go from 0 here, and then it's gonna intersect again. That's the one you're looking for. This one's at 0, but you're looking for this one. Okay. So yeah, pretty simple, guys. Here, honestly, I don't like the way this one's worded too well. So crossbar on a field goal post, right? Write an inequality to find the x values where the ball is high enough to go over the crossbar. So basically, this equation here is the height of your kick. So you have negative 0.02 x squared plus 12x. And in order, I don't know if you guys are super familiar with football, but in order for you to get the points, you have to make it over that crossbar. So you need that height to be greater than, not equal to. If it's equal to, it'll hit the crossbar. But if it's greater than 10, then it will be good. So there's your inequality. Oh, shoot. I'm sorry. I wrote that in the wrong spot. But it's the same idea. So you write this out. But again, you need it to be greater than that 10 yards. I'm sorry, 10 feet above the ground. To graph it, guys, all you're going to do is move that 10 over and put a y on that side. So it's going to be y is less than, right, negative 0.02x squared plus 12x minus 10. And then you're going to graph it, right? And then you're going to evaluate all these things. Again, I don't have a graphing calculator, I'm sorry, but we'll talk about these on Monday. We'll just make sure we all have the right equations and stuff like that, okay? Down here, this one's super easy, guys. This one on it only asks for real solutions. Real solutions, meaning another way of writing that, real solutions just equals times touches x-axis. Times it touches the x-axis. How many times does this touch? 1, 2. So 2 real roots. How many times does this touch? 0 real roots. How many times does this touch? 1 real root. How many times does this touch? 2 real roots. All right, pretty simple. Down here again, guys, remember we decided to do away with focus and directrix. There was no reason to. I don't see a reason to. So if those of you who are, who panic all the time, you probably read that and, just got panicky. But don't worry about it. Focus and directrix is not something I'm worried about, so it's not something you should be worried about, okay? But really all you're doing here, guys, is graphing. So remember, your vertex, this is vertex form. Vertex is going to be -5, -1. So -5, -1, right there. And then really all you're doing, oh, sorry, I didn't realize there was a spot for it, but down here. So then your axis of symmetry is at -5, right? It's always your x value of your vertex. They're just plugging things in around it, guys. So I'm going to plug in a -4, negative, oh, I should go in order. So I'm going to plug in a -7, a -6, a -4, a -3, and a -2. Okay, so I'll plug those in and fill those in and graph them right now. All right. Oh, I didn't graph them. Hang on a second. All right, so there it is, graphed and done. So yeah, bang, bang, bang. Okay, distance formula. What? That's super cute. Okay, I'm trying to do a review here, please. Thank you. I'm just kidding. Okay, so use the distance formula. Yeah, don't worry about directrix and focus. We're not worried about that. Okay, so add the following complex numbers. This is super easy, guys. Just combine like terms. So 3 plus 5 is 8. 2 plus 7 is 9i. Bang, bang. All right. Subtract the following. No big deal. Okay, what did I teach y'all? To distribute that negative to make it easier on yourself. So rewrite this. 6 plus 5i minus 4 minus 3i. And then combine like terms. 6 and -4 is going to equal 2. 5 and -3 is also going to equal 2. I. Bang. Okay. I don't know why I'm doing it. So 5i times -4. Oh, sorry. I just dove right in. So you're just going to distribute that 5i, guys. No big deal. So 5i times -4 is going to be -20i. 5i times 2i is going to be a 10i squared. That I squared is going to turn into a -1. And then you got to write this in standard form. So this is going to be -10 minus 20i. Right, pretty simple. Pretty simple. This one you just have to FOIL. I'm going to zoom in for this because I need the more room. So I'm going to FOIL. First outside, inside, last. 4 times 9 is 36. Outside is -8i. Inside is, ooh, I'm brain farting, 54i. And then last is going to be -12i squared. Again, you rewrite that I squared as -1. Rewrite everything the way it is. You can combine these. So that's actually going to be just a plus, 46i. And then change that to a +12. I'm going to come over here. So I have 36 plus 46i plus 12. Combine these like terms. So I have 48 plus 46i. Pretty simple. Pretty simple, right? Completing the square. Hey, we're almost done, guys. We're getting there. Completing the square. I'm going to do a couple of them and then pause it and do the rest of them just so you can kind of have the notes. I'm not going to talk through all of these. But remember, guys, so you need to bring the 5 over. Here. Right? And then you complete the square. So remember, completing the square, I've got to use this formula, b over 2 squared, to find that c value you're trying to look for. So b over 2 is going to be 4, squared is going to be 16, so I complete this square by adding 16, right? But what I do to one side, I've got to do to the other. So we got to add the 16 over here as well. So -5 plus 16 is going to be 11, and then I just factor this into being x plus 4 squared, and that still equals 11, and then it turns into the problems that were before, right? So now I'm going to take this and square root it. So I'm going to get x plus 4 equals plus or minus the square root of 11. Subtract 4 from both sides. Remember, that goes in front. So my x is going to equal -4 plus or minus the square root of 11. Right? I'll do one more with you guys, and then I'll pause it and do the rest. So let's do the second one. Okay. So here, again, first step has got to be to move that 4 over, that negative 4 over. Like so, right? And then I got to use this equation again, b over 2 squared, to get that missing c value. So negative 10 over 2 is negative 5. Squared is going to be positive 25. So h squared minus 10h plus 25 equals 4 plus 25. Right? These are the new things we're adding to both sides. So then I can factor this left side. So it's going to be h minus 5 squared. And then this right side is going to be 29. And then again, you just solve it, guys. So square root, h minus 5 on this side, a plus or minus 29 on the square root of 29 on this side. Add 5, we put that right up front. And there you go. Okay. So again, I'll pause it and do the rest of them for you so that you have those notes. Alright, and there's a screenshot of all the things. That was stupid, I know. So yeah, just pause the video, take the notes, make sure you're right, make sure I'm right, because I could have very well made a mistake. There you go, okay? So now down to here. Guys, we're almost done. Jeez, we're coming up on an hour. This video is ridiculous. Oh my god, okay. Y'all wasted my Sunday night. I hope you're happy with yourselves. Okay, so let's go through this. So the parent function here. Guys, honestly, I would just...
Spanish?
No, not Spanish. Ooh, that was my neck. Okay, so parent functions here. If you don't remember, guys, you should have notes on it. If not, just Google it, honestly. That's going to be the best thing for you, because just watching me do it is not going to help. Seeing the graph and finding out for yourself what it is going to be better for you. But this parent function is irrational, and its equation is 1 over x. This equation is absolute value. I'm sorry, this parent function is absolute value. And this is y equals this. What do you mean it's not doing it? Don't you do that to me. Okay. So then this one is a quadratic, what we spent like freaking years on already. Y equals x squared. Oh, stooge. Oh, what an idiot. I hope y'all caught it. I hope y'all called me an idiot when it happened, because that's not a rational function. What an idiot. Everybody makes mistakes. Everybody has those days. This is a cubic. Because this one is a rational. I know the teacher's an idiot, but it's okay. As long as we catch our mistakes. Learn from them. Okay. Cool. This one is an exponential. What we saw last time, exponential. I remember I put exponential. That was dumb. Okay, this one is just c to the x, where c is any number. Right, here is the log function. Logarithmic. I hope I spelled that right. Alright, that's just log of x. And then this one here is the square root function. No big deal. Okay. Describe the transformations. Again, there's 4. 1, 2, 3, 4. Reflect over x-axis, vertical, compress, right 1, and up 4. There you go. Okay. These absolute value ones, guys, I'm going to do one of them with you, and then I'll kind of pause and do just the notes, because it's pretty simple. It really is. And I think just the quick refresher is going to get you exactly where you need to be. So here we got to multiply both sides by 4. That's just simple algebra. because we have to isolate. We have to isolate this absolute value, get it by itself, so that we can split this off into two equations. After that, let me actually write this smaller. So I'm going to have absolute value. Right, because we need this split into two equations. I'm going to have a positive and I'm going to have a negative equation, right? So when I do that, right, my positive equation, I'm just going to drop the absolute value and keep my 8 positive. My negative equation, I'm going to drop the absolute value, but then make my 8 negative. Then I'm just solving just like it's an Algebra 1 problem. I'm going to add 4. Divide. So m equals -4, and again add a 4. Divide by -3. And my m equals 4/3. So there you go. Right. You just split it off into the two equations and then solve. So I'm going to pause and do the rest, and then unpause it for your notes. All right, here they are. I'm just kidding. Okay, so there it is. So pause it, take those notes down, make sure you're right, make sure I'm right, and all that good stuff. Okay, guys, we are almost done. This. No, really, there's only 3 more. Don't call me out like that in front of my students. They do enough of that. They abuse me enough. Okay? I just get abuse. I just get abuse everywhere I go, guys. You see, and y'all add to it. She adds to it. Everyone adds to it. I'm too nice. I just get abused. I'll just do the rest of the video, I guess. Just really sad. Because no one cares about me. So Luis receives a gift card worth $100 to an online retailer that sells digital music and games. I'm just kidding. Okay, so remember when we wrote these system of equations, guys, we always put money in the same equation, right? So, and then we put the other equation. So he wants to get 32 items all together. That's music and games, right? So I want my music plus my games to equal 32. And my music costs $1. So I'm just going to leave it as M. I'll put a 1. So $1 for music, $5 for games, and that's got to equal $100. Okay, and then you got to solve. So, yeah, so I'm going to multiply this equation times -1 so that I can solve. So I have m plus g equals 32, and then I'm going to have -m minus 5g equals -100. When I add these two equations together, these m's will cancel. I'll have -4g equals, what's that going to be, 68? Yeah, -68. Then I divide by -4. Oh, Lord. So then my g is going to be, oh, goodness, 17? Am I wrong? I'm just going to guess 17. If I'm wrong, I'm wrong. 17 games? I hope. And then my music, so I plug that back into an original equation. So I'm going to have m plus 17 equals 32. Subtract, and m equals 15. M equals 15. And you're done. Yeah, cool. Right, pretty simple. Same thing down here, guys. Again, put the money in the same equation, and then she wants to hit her target if she sells 20 items. So that's bracelets plus earrings equals 20 items. Attach the money to it, so $2 bracelets, $3 earrings, $55. And then I'm going to multiply this top equation by -2. So I'm going to get -2b plus -2, just say minus 2e equals negative 40. And then I just bring these guys over. Add these together. So these will cancel. This will be e. This will be 15. That's nice. E equals 15. Then I can plug this back into this guy up here. So let me put a different color. So then I have b plus 15 equals 20. Subtract 15. This ended up being really easy. B equals 5. There you go. Okay. Last but not least, quadratic formula. Don't forget to put this into standard form. So this is really this. Right, and then I just plug it into the quadratic formula. So remember, it's negative b plus or minus the square root of b squared minus 4ac over 2a. So when I plug these things in, I'm going to have a negative 5 plus or minus the square root of negative 5 squared minus 4 times a times c, all over 2 times 4. Remember, guys, I'm not too worried about this. Again, you're going to have a calculator. You can literally put that in the calculator, but I'll simplify it a little bit just so that we all have kind of the same answer, and then if you simplified it more, then more power to you. But we have 5 plus or minus 25 minus plus 16 over 8. And then again, that's going to be 5 plus or minus, what is that going to be, 31, 41 over 8. And there you go. All right. That about do it, everybody. We'll have time tomorrow on Monday to talk about this stuff. If you have any other questions, yeah. Hope y'all had a great weekend. See you tomorrow. Mr. G. Signing out. Peace.